Welcome back. So we started looking at limits of functions of two variables in the last video. Here's another example. Let's say I have the function f of xy, which is equal to xy squared over x squared plus y to the 4. And we want to find the limit of f as xy goes to the origin 0, 0. Now, so basically then what I'm going to do here first is I'm going to let xy approach the origin along any straight line. So let's say we take a straight line that passes through the origin, so the equation of that straight line would be y is equal to mx, right? So along this line, the value of the function would be what? Well, along this line we're going to replace y by mx, and so along this line the value of the function would be x mx squared over x squared plus mx squared, because this was, so we're replacing y by mx. And then if you simplify this, you get m squared x over 1 plus m to the 4 x squared. So you're going to multiply out here, you're going to write this as m squared x squared, and then you can factor out x squared. And if you do that, wait a minute, I think I have a typo here. There was a y to the 4, so this should be a y to the 4 here. Okay, so if you simplify that, that is, what you have to do is this would be m x cubed, m squared x cubed, and here you can factor out x squared, and then you get 1 plus m to the 4 x squared, and then you can do some cancellation. So this is what you get after you simplify this. So the value of the function along this line, on this line, is this. So then as xy approaches 0 along this line, well, that would mean x goes to 0 here, and then we see that the limit is 0, because if x is 0 here, then we get 0 here. So we see that the limit of f is 0 as xy approaches 0, 0 along any straight line passing through the origin. Well, does that mean that the limit is indeed 0? Well, let's see what happens when we approach the origin along this parabola. So notice that this is a parabola that opens to the right. So now we are approaching the origin along this parabola. So in that case, what's the limit? Well, now along this parabola, x is y squared. So then on this parabola, what's the value of the function? Well, recall that the function was this. So in this function, we're going to replace x by y squared. So we're going to get y to the 4. So replace x by y squared. We're going to get y to the 4 plus y to the 4. So then notice that I'm going to get y to the 4 divided by, I have a typo here, this should be y to the 4. Again, let me show you the function. So the function is right here. So you're replacing x by y squared. So you get y to the 4 here. Replace x by y squared. So that's going to give you y to the 4. So y to the 4, y to the 4, y to the 4. So that's going to be this. And that is exactly half. So we see that as xy approaches 0, 0, along this parabola, the limit of the function is half, which is not the same as 0. So you see that in this case, the function has limit 0 along any straight line passing through the origin, yet the limit isn't 0, yet the limit along a parabola is different. So the limit of f is the limit of f doesn't exist then. Okay, so I hope this example has explained that the limit of a function of two variables is a bit more complicated than the limit of a function of one variable. We say that a function f is continuous at a point AB if the limit of f at AB, I have a typo here, it should be the point AB, the limit of f as xy approaches AB is equal to f of AB. For example, if I have this function f of xy, which is like a polynomial in two variables x and y, then this is going to be a continuous function on R2. If I have this function g of xy, where this is the ratio of two polynomials in x and y, then notice that this would be continuous on the entire R2 except where the denominator vanishes. Well, the denominator vanishes when x and y are both 0 here. So this function is continuous everywhere except the origin. So this symbol means from the set of from R2 this is the set of all points in R2 except the origin. Okay, so let's see how many minutes I have used. Okay, so one last example. Let's say we want to take the limit of 3x squared y over x squared plus y squared as xy approaches 0, 0. Now this limit, you can check that this limit is 0 along any line and any parabolas, but that's not enough to say that the limit is 0, because there are curves that we can approach the origin along other curves that are not lines or parabolas. So the limit, even though the limit is 0 along lines and parabolas, that's not enough to say that the limit is 0. But let's see how we can show that the limit of this quantity is 0. Since the limit is 0 along lines and parabolas, maybe that gives us some confidence that the limit is 0. So now the job is to show that the limit is indeed 0. So how do I do that? Well, we take the absolute value of the function. So we take the absolute value of this function. So observe that the absolute value of the function is equal to 3 times x squared over x squared plus y squared times the absolute value of y. Well, the reason I could do that is because x squared and the x squared plus y squared, they are all non-negative, so I don't need to put absolute value sign here. Now, clearly the fraction x squared over x squared plus y squared is less than or equal to 1. So this quantity here is less than 1 because the numerator is smaller than the denominator. So this is less than 1. So as a result, I see that this is less than 3 times the absolute value of y. And clearly the absolute value of y is less than root of x squared plus y squared. Why? Because I have this x squared term. If I don't have the this non-negative term x squared, then root of y squared is the same as the absolute value of y. So clearly absolute value of y is less than root of x squared plus y squared. So then I have 3 times that is less than 3 times this. So basically then what I got is that the absolute value of the given function is less than 3 times the root of x squared plus y squared. Now notice that the limit of this quantity is 0 as xy approaches the origin, and therefore the limit of this quantity would also be 0. So the limit as xy goes to 0, 0 of 3x squared y over x squared plus y squared is 0 as well. So here we have proved that this limit is 0. Okay, so that's all I'm going to say about limits, and in the next video we will start talking about derivatives of multivariable functions. In particular, we will start talking about partial derivatives.